Hi everyone, let us discuss this example. So in this example we have this function and we have to verify Rolle's mean value theorem. In previous video we have already seen Rolle's mean value theorem. Let us recall the statement, then we will solve this problem. Theorem says if function is continuous on closed interval AB, function is differentiable on open interval AB, f of A is equal to f of B. That means if function satisfies these three conditions, we say there exists some point C belongs to open interval AB such that f dash of C is equal to 0. So this is statement of Rolle's theorem, and yes, we have to verify it here. So yes, I have written a given function here. You can easily see this is a polynomial function. We know that if you have any polynomial function, it is always continuous and it is always differentiable, right? So let me mention here f is polynomial function f is polynomial implies f is continuous on what is the given interval? Minus root 2 root 2. So irrespective of any interval, if you have any polynomial function, it is continuous. So that's why we can easily write it. The same thing is for differentiable function. If you have polynomial function, it is 100% differentiable on a given interval. So and f is polynomial function. Let me write here same reason. It is a polynomial function. So therefore f is differentiable on open interval minus root 2 comma root 2. In a definition of Rolle's theorem, right, statement of Rolle's theorem, sorry, we take a open interval for a differentiability getting. So that's why I mentioned open interval minus root 2 comma root 2, right? See, let us go for the last condition. The last condition is f of A is equal to f of B. What is A here? Minus root 2. What is B here? Root 2. So let us find the values. First of all, I will find f of A. Okay, so let us do that here. Consider f of minus root 2. That meant at a place of x we have to put minus root 2. So it will be 2 minus root 2 cube plus minus root 2 square minus 4 minus root 2 and minus 2. Let us simplify. If you take cube of any negative number, 101% it is negative, minus 2. Root 2 cube, that means root 2 into root 2 into root 2. So you will have 2 root 2 into this 2, that means I should write 4 root 2, right? Square of minus is plus here, root 2 square is 2, minus minus plus 4 root 2 minus 2. See, all terms will get cancelled to each other. They are having opposite signs. So that's why its value will be 0. So now let us find f of b. That means f of root 2. Right? Since our b is root 2. So let us replace x by root 2 in f of x. So we will have here 2 root 2 cube plus root 2 square minus 4 root 2 minus 2. Root 2 cube is 2 root 2 into this 2, that means 4 root 2, its square will be 2 minus 4 root 2 minus 2, all terms will get cancelled 0. So here also we have got 0, here also 0. So what I want to say, therefore f of minus root 2 is equal to f of root 2, that means f of A is equal to f of B. All conditions of Rolle's mean value theorem are satisfied, therefore we can apply Rolle's mean value theorem. So therefore by Rolle's mean value theorem says there exists some C belongs to that minus root 2 comma root 2 such that f dash of C is equal to 0. There is some point between minus root 2 and root 2 such that derivative of f at that point is 0. This thing we have to verify. As you can see here, we have to verify Rolle's theorem. So that means we will actually find the value of C and we will check whether that C lies in that interval or not. Okay, so there is no more space to write. Make a screenshot of it, then we will go further. Okay, so this part is enough to write the remaining part of this example, right? So what we have f of x, let us find derivative first. Now f dash of x. So you know that how to find derivative. 2 is constant, derivative of x cube is 3x square, plus derivative of x square is 2x, derivative of minus 4x is minus 4, and 2 is constant, derivative will be 0. Okay, so this thing we have, that means 6x square plus 2x minus 4. So then consider, I am going to consider that f dash of x is equal to 0. So that means 6x square plus 2x minus 4 is equal to 0, right? See, all terms are divisible by 2. Make it more simple. So 3x square plus x minus 2 is equal to 0. We have to find factors now. Product should be minus 6, sum should be plus 1. So I think product should be minus 6, sum should be plus 1. So plus 3 minus 2. So let me write here. Okay. Okay, I'm going to write it here. So 3x square plus 3x minus 2x minus 2. Tell me what can we take common from first two terms? 3x. So in bracket we have x plus 1, and from last two terms we can take minus 2. So x plus 1. So the first bracket is x plus 1 and the second is 3x minus 2. Okay. So that means either first bracket is 0 or the second bracket is 0, obviously. So therefore x plus 1 is 0 or 3x minus 2 is 0. It gives x is equal to minus 1 and x is equal to 2 by 3. But see, both numbers minus 1 and 2 by 3, both numbers lie in this interval. So belongs to minus root 2 comma root 2. Actually we were in search of one single point such that f dash of c is equal to 0. Rolle's theorem says there exists a point, but here fortunately we are getting 2 points. So I can mention here. So yes, for these values of c, we get f dash of c is equal to 0, right? So yes, the Rolle's theorem is verified now. So therefore, Rolle's theorem is verified. In this way we finish it, right? Make a screenshot of it, then we will stop. Thank you. Bye bye.